We were talking about the standardization of the solution. So this stuff here, this is a hydrochloric acid solution. So let's say this is the beaker, and we have some hydrochloric acid solution. And I know the molarity of this one. So let's say this is the 0. Maybe it's given somewhere here. So let's say 0.0 molar, 0.01 molarity. So this is the hydrochloric acid solution in the beaker. So the molarity of this solution, either I prepare or somebody give me, it's a 0.01 molar. Yeah. So the hydrochloric acid here is a pure compound, and I know it is stable. Make sense? So so you have another solution here. So this solution is the sodium hydroxide. This is sodium hydroxide solution. So sodium hydroxide is dissolved in water. I don't know the molarity of this solution. So I know everything about this guy, but I don't know anything about this one, right? So what is the molarity? Molarity is equals to how much? So by using this solution, I'm going to find the molarity of this solution. So I'm going to standardize this one, yeah? Like standardize. What is standardize mean? Standardize means find something or make something, right? So I'm going to find the molarity of this one using this solution. So this is the standard solution. I need to standardize this solution. This is the unknown solution, yeah? So the molarity of this is unknown. Make sense? So this process is called titration. So what I do is, so this is called burette. So this is called burette. here. So this is a volume measuring device. This is called burette, and this has a stop cock here. So I fill the sodium hydroxide. So I have a lot of sodium hydroxide solution here. So this is level. So 0, so like this. So 0 is here, 5, 10, 15, 20, 25, 30, 35, maybe 40. So it's a level like this. So this is all in milliliter. Make sense? So this is called burette. So this is called burette, burette. So we will do this experiment in lab number 7 next week. So you will know. So burette. So I'm going to put this sodium hydroxide solution in this one. So I feel like this. So I put that solution here. So I take the beaker and then just pour it here and fill up to 0. So make sense? Up to 0 here. Good. Now this hydrochloric acid solution I'm going to take in some class called Erlenmeyer class. So you already know the Erlenmeyer class that you use in the lab number 6. So like this is cones like this. So Erlenmeyer class. So how much I take this solution here? So take 25 ml solution to 0.01. So here I put 25 ml. So I use some pipette and take 25 ml of solution and put it here. 25 ml solution. Make sense? So I take just 25 ml of solution and put in that Erlenmeyer class. Yeah. Now I need to put a indicator. Indicator means if I put something in acid, it gives one color. But if I put that thing in the base, either it doesn't give any color or its color changes. Make sense? So I'm going to put some indicator. So indicator. So I put couple of drop of indicator. So in this case, I put phenolphthalein. So it's a compound. You don't have to understand here. Phenolphthalein. Phalin. Phenolphthalein. So I put couple of drop of indicator here, and it's a colorless. No color here. Because I put the phenolphthalein in acid, so this is acid, hydrochloric acid. So phenolphthalein doesn't give color in acid, so it's a colorless. Now I don't have a color here. Make sense? So I'm going to put this here, like this here. That's my flask here, and I bring it here and put it here like this. So you will understand in lab number 7. So like this. So I have 25 ml of how much I put there is a 25 ml, right? So 25 ml solution of HCl I put there. So this is 25 ml solution here. 25 ml solution of HCl. Good. And I know the molarity of HCl. So what's the molarity of that HCl? 0.01. So molarity is 0.01. I already know the molarity of this time. So I don't know anything about this time, right? Everything I know here. So I put a little bit phenolphthalein. So what I do is I just open this one. So I can open this one. So I open this one and start to the elements start to go down here. Make sense? And I just keep shaking, keep shaking, keep shaking. Just how we did the reaction in zinc iodide. So I just try to do the reaction by shaking, right? So this comes down and comes down here, and so I keep increasing the solution. And somewhere let's say when I reach about 20, so this now gives the color here. Now you will see the red color there or the pink color there. Put the color there. So you are just open this one, and this solution, sodium hydroxide solution, that's a sodium hydroxide solution start to come down, and at a certain point you see all the solution now become pink. Okay, so previously it was colorless, just like water. Now it becomes pink. Right? So when it just you need to stop this one. Yeah, you stop this one and record the volume. So when I was in 20, it turns to be the pink. So this is my in point. So we call this as in point. The reaction is just complete when it comes to pink here. So now let's do the calculation. So the volume I put from here? So 0 to 20. So that volume is, so that let's say V2 is 20 ml. 20 ml. Do I know the concentration of this solution? The molarity? I don't know, right? I'm trying to find the molarity. I don't know. M2 of that solution, I don't know what. So, but I know everything about this one. So the volume of this one, V1 is 25, and the molarity of this one M1 is 0.01 molar. Good. Now I need to just use that formula that we had previously. So V1 M1 is equals to V2 M2. So this is our formula. So V1 is 25, M1 is 0.01, V2 is, how much I put here from here? 20, so that's 20. So this is acid, this is base, 20, and I don't know the molarity. Molarity, I don't know. Now I'm going to calculate the molarity of this solution is 25 multiplied by 0.01 divided by 20 is equals to M2. So it just so I think I put the 12 ml there, but I put the 20 here. That's fine. So you just multiply and divide, whatever the number comes, that's the molarity of anyway. Yeah. So suppose it was just come up to 12 ml here. So this is 10, 11, 12, somewhere here. So I all have up to here anyway. And so when you put the 12 ml, it just turn to pink. So in that case, so V2 would be 12 here. So that's writing 12 ml there. 12 ml, and you would put that 12 here, and M2 would be divided by 12 here. So 0.02. Yeah, something like that. Easy. Good. So we just turn the color and look the volume and use the V1 multiply M1 is equals to V2 multiply M2. Good. And calculate that. So we will do this in that lab next week. So let's do some problem here. So this is called standardization. So I just standardize the sodium hydroxide solution using the hydrochloric acid. So hydrochloric acid is very pure. So I know everything about that hydrochloric acid. I don't know anything about sodium hydroxide. Now I know after titration, I know what is the molarity of sodium hydroxide, right? So this is called the process of standardization. And sometimes they call this is a titration. Like that one. So this is a hydrochloric acid. This is a base here. So here they put some a couple of drops of phenolphthalein indicator here. When you start to put the sodium hydroxide from here to here, you can start to see the color here, but the color just comes and disappears. Color comes and disappears. Color comes and disappears. But at certain point, when you put a lot of sodium hydroxide from here, the color appears and doesn't go on. That means the reaction is just complete, and you see the color like this, and we stop here, and that's the volume of the sodium hydroxide we put there. Yeah. Everybody got that? But when we do the experiment, we will know more. Yeah. So let's do some of the problem here. So the problem here is it's asking 12 ml of 0.15 molar HCl solution was required to neutralize 0.20 molar solution of NaOH. What is the volume? So let's look here. So it really doesn't matter which solution you take in the Erlenmeyer class or in the Burette. So here basically they are taking hydrochloric acid here, and then amount of hydrochloric acid 12 ml. So the V1 they are putting here is a 12 ml, right? You can write the 12.0. So in experiment, when we go to do the work in laboratory, we don't write the 12, we write 12.0. Yeah. So 12 ml of 12.0 ml of the hydrochloric acid, and the molarity of this one, we already know that that is 0.15 molar. So I know everything about this one. So this two number means I know everything about that one. What, how much HCl is there in that solution. So required to neutralize the 0.20 molar solution of NaOH. So they put the NaOH solution here, and they know the molarity of NaOH. So that is 0.20 molarity. So we know that one. And then we put this so we put that this one on of this O here, that sodium hydroxide, and we bring that flask and put it here, and we put a couple of drops of indicator, and it's colorless now. Now I open it and it goes down, and at a certain point, the red color appears, and that red color stays there. It doesn't disappear. Make sense? So when I put the NaOH from here to the acid solution, when I put one drop, the pink color appear and go away. I put again, pink color appear and go away. But at a certain point, when I keep continue putting it here, at a certain point, so at that point the pink color comes here and doesn't go away. Yeah, that means that the reaction is just complete. Good. And so it is saying that when I give to what volume? So I don't know at what volume when I reach here. I don't know at what volume I reach here. So at that point the pink color appears, right? So I don't know the volume. So this volume I don't know, but I know this one. So my formula is V1 M1 is equals to V2 M2. So V1 M1 I already know everything. So V1 is 12, M1 is 0.15. So that's acid. Now the base. So for the base, they give the molarity, that is 0.20 molar. I don't know how much volume I need to put from here to here so that the pink color appear and stays there. Okay? So that's a V2. So I don't know that V2. So let's calculate V2. So that's 12 multiply 0.15 divided by 0.20 is equals to V2. So that number gives 9 ml. So when my solution goes from 0 to somewhere here, so the pink color still comes there, it stays there, it does not disappear. Okay? Everybody got it? So you will know next week. So we will be doing this one in lab 7. So look here, the balance. Balance is number 1, 1. So we are just doing this here. There is 1, 1, 1. So we'll also in next one something here. So let's look this one. It's a little bit different. So previously, when I looked, there was HCl and NaOH. So in front of HCl, there was 1. In front of NaOH, there was 1, and in front of HCl, there was 1. So that was the 1-to-1 reaction. But this reaction, if you look here, this reaction is not 1-to-1. So they are reacting this one, the acetic acid. So I don't know what they are. So what's the volume of the that's acetic acid, yeah? So acetic acid C2H3O2, H3O2 and H. So they are writing like this way in our book. So I just type that there, and they are reacting with calcium hydroxide. So this is acid, this is base, and when we react this one, they form calcium acetate C2H3 O2 plus 2H2O like this. So look here. So they balance this reaction and they put 2 here, and they put 1 here. So now this is balanced, right? So we are doing the reaction between this guy and this guy, so we don't have to worry about this one. Yeah. So this is acid, this is base, right? So we are just doing the acid-base neutralization. So how much? What volume of 0.600 molar acetic acid is required to neutralize 25 ml of this molar of molarity of calcium hydroxide. So this is the base is given here. So base is, so the base, let's say V1 M1. So let's say that's a base, it's equals to V2 M2. So let's say this is acid. So base is it's a base, right? So this one 25 and 1.175. So that's a base because that's a CaOH2. That's a base, and I have the molarity of acetic acid, but I don't have the volume here. So see here. So I know everything about this one. I don't know about this one. Now, what we should look here is this number are not 1 and 1 now. Previously there was 1, there was 1. So I have 1 and 1 down here, so I was good. So if here was 1 and there was 1, I put 1 here, and so I don't have to put 1 here because 1 doesn't make any difference, right? Now, who is strong here? Look here. Is CaOH strong or acetic acid is strong here? 2 acetic acid is equals to 1 calcium hydroxide, right? So calcium hydroxide is too strong here in this reaction. Make sense? So it's just like 2 goat is equals to, just like that, 2 goat. If it is a goat, 2 goat is equals to 1 cow, something like this, right? So who is strong here? This is too strong. So this is weak. So they are putting 2 here, right? Make sense? So like that. So if this is a V1 M1 is a V1 M1 is an acid. So this is acid. So this guy is weak guy, right? So this guy is strong guy. So CaOH2. So I put, did I do mistake here? So let's say moles of acid is 2 there. Who is strong? So this guy is strong, definitely. Yeah, this guy is strong. So this guy VPM is strong guy. So what's the basic? Yeah, moles of base. That's right. So that's very strong. So moles of this is strong. So this is that weak. Moles of acid. Did I do right or wrong here? I'm just trying to figure out. So which one is strong? So this guy is very strong. So this guy is very strong. So let's do this one. I put into this one, and then we'll figure out. So this is 1. So there is 2 here. So I put 2 there. So there is 1 there. So I put 1 there. So so let's do V1. So what is the V1 we have? So V1 I was doing. V1 is acid. So acid is this guy, right? Acid. So I don't know V1. So V1 is acid. So 0.600. That's M1. So V1 I don't know. Divided by 2 is equals to V2 M2. So V2 is 25 and 0.175. So this is 25 multiplied by 0.175. 175. So so 2 goes here. So V1 is equals to 25 multiplied by 0.175. So 2 goes here. 25, and then 2 goes here. Then 0.600 comes here, right? So that's a V1. So how much I get that one? So that's 14.5 ml. 14.5 ml of acid. I need to neutralize that one. another way also I could do this one. So let's see another way. So what I could do is like this. So how many moles I have here? 25 milliliter. So 25 milliliter, 25.0 milliliter of solution. The molarity is 0.175. 0.175. This is the molarity. This is the volume. So how many moles here? So I can convert this milliliter to liter. So that comes to be 0.025 liter, right? So milliliter to liter. Make sense? So that's liter. And this is the molarity. So if I have a molarity and liter, I can find the number of moles. So number of moles is equals to, so maybe I write this way. So molarity is equals to number of moles divided by liter. So liter goes here. So liter multiplied by the molarity gives me number of moles. So liter multiplied by the molarity gives me number of moles. So that is 0.025 multiplied by 0.175 gives the number of moles of the this guy, the base. So I could put that base here. So how many mole I have here is 0.025 multiplied by 0.175. 175. You can multiply there and put it like that. And how many moles of this guy I need? So I could put x here and I just take the ratio. So x by 2 is equals to 0.025 multiplied by 0.175 divided by 1. So I can also calculate the number of moles of acid I need. So from here I would get. So I did both ways. So some of the problem I did this problem both way in the lecture notes, so you can compare there. So let's do this one. So how many mole I have here? So this is 0.025 multiplied by 0.175 and then multiply by 2, right? So that many moles. So 0.00 so this is x is equals to 0.00875 moles of acid I need, right? To do that utilization. So we have been doing the same thing like this previously. Now I need to find the molarity is given. So I need to find what is the volume? I need to find the volume. So now molarity is equals to number of moles divided by the volume, right? Divided by the volume. So I need to find that volume. So molarity is 0.600, and number of moles. I just find that 0.00875, and then volume. I need to find this volume. So I put that volume this way. So volume goes here and this comes there. So that is 0.00875 divided by 0.600. So this gives me how much? So that comes to be 0.00145 liter, because this formula gives the liter. Moles by volume is a liter, right? So that's a liter. Now you can convert that liter to milliliter. So milliliter would be 0.0145 liter multiplied by 1000 milliliter divided by 1 liter. So like that, liter cancel, and when you multiply that one, this is 14.5 milliliters. So both ways, did you get a 14.5 here? Yeah, 14.5 milliliter here. So I try to doing both ways this problem in the in this slide, so you can look there, yeah. So like this one, And let's look another problem here. So you can do either this way or that way. But I find this easy. V1 M1 is equals to V2 M2. That is much easier during titration. So here is a problem. It says how many milliliters, again the volume, how many milliliters, what is the volume we need of potassium permanganate. So let's write the reaction first. So the reaction is this one, manganese MnO4 reacting with 5 Fe2 plus. So this is the reaction. So the reaction is this one. And when we do the balance, here is 1 and here is 5. Here is 5, right? So if this guy, if you are going to write V1 M1 for this guy and V2 M2 for this guy, so who is stronger here? So V1 M1 is KMnO4, V2 M2 for this one. So this is a bigger number here. So you are going to divide that by 5 here. See, so this way there is only 1. So then you are going to put 1 here. So that's how this formula works. If there was a like this, either you do this way or you can do another way also. So for example, if I was doing like this, so here is 1, here is 1. So the number of mole V1 M1, so they are equally strong, right? 1 1. So V1 M1 is equals to V2 M2. So like that. So but if so this formula works this way. But if there was something like this, so let's say I write the S2SO4 here, S2SO4 and 2 NaOH here, something like this. So this is 1, this is 2. So in that case, you need to write this 2 down here and this 1 down here like this. Yeah, either you do this way or you just convert that, multiply the volume and molarity and get the number of moles and calculate the number of moles of the another reactants and again use the molarity equals to number of moles by liter, or you do this way. Yeah. So like this one. So since potassium permanganate is 1, so I put that 1 here. Iron is the 5 here. So this is 5 here. So that I put 5 here. Make sense? So let's put the number there now. So how many milliliters of potassium permanganate? So this is potassium permanganate in my left side. So how many milliliters? So V1 that I don't do. The volume I don't do, right? So potassium permanganate, the M1, the molarity of potassium permanganate is 0.247. 0.247 is equals to V2M2. Now this is for the iron. So required to fully react with the 50 ml of 255 millimolar iron sulfate solution. So 50. So I know the volume. That's V2 is 50. And then what is the molarity of that solution? 255 millimolar. So 255 millimolar. So the millimolar should be converted to molarity. So one molar is equals to 1000 millimolar like this. So this millimolar should be converted to 1000 millimolar. Sorry, the molar. So that I need molar. So I put molar up here and 1000 millimolar here. Millimolar here. So millimolar cancel. 255 by 1000 gives me 0.255 molar. So 0.255 molar. So I already write the left part. Now right part is V2. What is the volume of the iron sulfate there? So 50. So that's 50. And then what is the molarity of the iron sulfate? That's 255 millimolar is 0.255 molar. 0.255 molar. Right? Now I need to calculate this value. V1 is equals to, so this number goes down here. 50 multiply 0.255 divided by 0.247. So whatever number comes there, that is the amount of the potassium permanganate I need. Make sense? So maybe this is V1 M1 by V1 M1 is equal to V2 M2 is a more easier way to do during the exam. Yeah. So which is a bigger number? So toward the bigger number, just divide by that bigger number, and toward the smaller number, put that smaller number. That's 1 here, so I didn't put there. So did I write the 5 here? I didn't write the 5 here, so I need to put 5 here. Still 5 here. Make sense? Got it? So we'll do some more problem, and so you will do this. So that gives us 10.32, something like that. All right, I have more problem here. So citation, some practice questions are here. So what I showed previously, two ways of doing things, I am solving by 2 ways here. So I think rather than this method, maybe this method is easier. So you may try just M1 V1 equals to M2 V2, right? Right. So I'm just doing 2 ways here. So let's write the reaction first here. So the reaction is we are titrating the sulfuric acid with sodium hydroxide according to that reaction. So 1 sulfuric acid plus 2 sodium hydroxide. So we are titrating like that to give sodium sulfate in water. Sodium sulfate in water. Na2SO4 plus water. Now let's look the balance there. So that is 1, 2, 1, 1. So 1, 2, so 1, 1, right? So we are just reacting this one and this one. So let's say the volume and molarity of this guy is V1, M1. So there is 1, so I put 1 here. Make sense? Or if you are confused why it comes there, so it's there is a reason behind that, but either way you can do that. So here, this is V2, M2, so this is 2 here, so I put 2 here. Yeah, so this is 2 strong, so this needs to double. So to make it equal, we need to divide this side by 2, so that the number of moles of this moles and number of this moles become equal. Yeah, so this way is there is 2, so I put 2 here. This way is 1 there, so I put 1 there. So sulfuric acid side, let's do V1 M1. So what is the sulfuric acid side there? Sulfuric acid is 10 ml and 0.12. So this is 10 ml and 0.12. So that is 10 ml and 0.12 molar. And we don't have anything here 1. So it's equals to what is V2 by 2. So anyway, solution was added. From the unit, it took 30 ml to reach the endpoint 30 ml. So we have a 30 ml here. So V2 is 30 ml, and I don't know the M2. So the molarity I don't know, and I have a 2 here, so I need to put that guy here too. Yeah. So if both sides, if there was a 1 and there was 1, I will just do V1 is equals to V2 M2. Yeah. Make sense? So look here. So that gives me, so 2 goes this way. So 10 multiplied by 0.12 multiplied by this 2 goes this way. 30 goes down here. So that is equals to M2. So what is the molarity? So that comes 2 multiplied by 0.12 multiplied by 10 divided by 30 gives me 0.08 molar. So 0.08 molar. Got it? So just in case why I am doing dividing 2 here, if you don't know here, you can go here and just to look this another method. Yeah, why that 2 comes there. So exactly the same thing that I showed previously. So I will use a but I think this is the much easier way, much easier way when you are taking exam or something. But time is too fast. So if you want to do this another way, So you could do this like this. So that I have a sulfuric acid is given, right? 10 ml and 0.12 solution of sulfuric acid is given. So you could do another way is like this. So molarity is equals to number of moles divided by liter, like this. So molarity is given, liter is given. So molarity is 0.12, 0.12, and then liter is how many liter? So 10 milliliter. 10 milliliter divided by 1000 is 0.010 liter, right? So 10 milliliter is like this. So 10 milliliter. So 1 milliliter is equals to 1 liter is equals to 1000 milliliter. So 1000 milliliter and 1 liter here. So milliliter cancel. So that comes to be 0.010 liter. So you could do something like that. So here 0.12 equals to number of moles divided by 0.010 liter. So number of moles. Now we can calculate number of moles from here. So that goes this way and multiply there. So 0.010 multiply by 12 gives you 0.0012. 0.0012. So this is sulfuric acid. Now you can put that sulfuric acid mole here, 0.0012. Now we don't know the number of moles required here, so I will put X there. So I take the X divided by 2 is equals to 0.0012 divided by 1. So you can get X is equals to 0.0024 moles. So that many moles of sodium hydroxide you will take, right? Make sense? And then when you do the moles, and then you do the molarity. Now, how many milliliter NaOH volume would require? So you have a formula. Molarity is equal to number of moles divided by liter here. So molarity. Do you have a molarity there? So 30 ml is the in point, right? So 30 ml. So we have a liter here. 30 ml. What is the concentration of NaOH? So see, we are calculating the molarity here. Concentration means molarity. So number of moles I just got 0.0024 moles of NaOH and liter. So they are asking me, they are giving me 30 milliliter is required. So 30 milliliter of NaOH is required. So 30 milliliter would be 1 liter divided by 1000 milliliter, and milliliter cancel. So that would be 0.030. So you can put 0.030 here, and that gives the molarity. So either way, give the same answer. Yeah. But maybe the previous is easier. Just V1 M1 is equals to V2 M2. So whichever has a small number, just put that small number that side. The which have a bigger number, put that bigger number that side, and you can easily calculate. Yeah. So either way. So some professors see that way, some would talk this way. So I'll just get both methods here. So let's look one, and then we'll be done. So another question here. So this question, we are titrating the sodium carbonate with hydrochloric acid. So we have sodium carbonate solution, and we are titrating with the hydrochloric acid, and we are getting NaCl plus H2O plus CO2, right? Plus CO2, and it's a balance according to 1 to 2. So this there is 1. There is 2, and there is 2, and all other are 1, right? So our formula would be what? So this formula for this one is M1 V1 by 1, because there is a 1, and we have this is V2 M2 divided by 2. Make sense? So put the smaller number where there is smaller side, put that bigger number Yeah. Everybody got that? So now let's put the value there. So M1. So 15 ml of 0.1 m sodium carbonate. So M1 given. So this guy is M1 is 0.1. V1 is 15. So 0.1 and 15 divided by 1. You don't have to write the 1 there because doing multiplying or dividing by 1 does not do anything. And then to the HCl side, we have HCl and so 25.6 ml of acid. So 25.6. So 25.6 ml of acid here, and I don't know the molarity here, so I write M2. That M2 and then divide by 2 here. Now my job is to find the value of M2. Make sense? Good. So V1 M1 is equals to V2 M2 is always same when we are doing the dilution. Last week when we were doing the dilution, we are not doing the reaction. We are just diluting. We are dumping the water there, right? So I have some hydrochloric acid or something, and I dump water. So that formula is always V1 M1 equals to V2 M2. But when we are doing the reaction like this, we need to look the mole ratio there. Yeah. So how much comes here? The 2 goes this way, 0.1 multiplied by 2 multiplied by 15, and this guy goes down here, 25.6 equals to M. So that's the molarity of sodium carbonate weightage. So 0.1 multiplied by 2 multiplied by 15 divided by 25.6. Sure. For sure, you will get the questions from this titration and dilution. Yeah. Dilution, when it says a dilution. So for example, you take some hydrochloric acid, let's say 0.1 molar. So let's say 1 molar, and you have a 1 molar hydrochloric acid. You want to make let's say 10 milliliter of 0.1 molar, right? 10 milliliter of 0.1 molar. So this is V2, this is M2. So how much volume you should take from here? So V1 M1 is equals to V2 M2. So in such case, in dilution case, this formula is always V1 equals to V2 M2. You are just dumping water. It's not the reaction. Make sense? So when just you are diluting the solution, V1 M1 is equals to V2 M2. There is no number below them. Yeah. So but when you are doing the titration, doing the reaction, two things you are doing the reaction, this number should take into account here. Make sense? So titration, when you are doing the titration, acid base, you are doing mixing two kinds of solution, and in those cases, this number and this number comes to play. But when you are diluting, dumping water in certain chemical and making bigger amount, diluting, in that case, V1 M1 is equal to always V2 M2. There is no number beneath them. Make sense? So just practice it, and how do you feel? And I have this V1 M1 is equal to V2 M2 divide by 1 and 2. So those coefficients may help you. So I also do another way here. So you also try this way also, and which one you feel easy, just practice that. Yeah. So this titration is very important concept, and that will be an exam. And I am going to post another homework, homework 5. So there are a lot of this titration problem and dilution problem like that. Yeah. The titration and dilution is really important problem. Yeah. Everyone got it? So try that. So V1 M1 equals to V2 M2. And where is the bigger number? Just put bigger side. Where is the smaller number? Put the smaller side, and always work. Yeah. In our time, when I was a student, there was we are working with the molarity here now, right? Molarity. But in our time, we didn't use that much molarity. We used to use the normality. Normality, that's another concept of normality. Now all book remove that normality concept. There is no normality in the book now. Yeah. So we just use the molarity, and when we use the molarity, we always put this kind of the number. Yeah. Good. So in normality, we used to use V1 M1 equals to V1 N1 is equals to V2 N2 always. So that's another concept. Yeah. So if you are interested, you can go and Google what is normality. Yeah. So that's another concept in chemistry, but these days they just remove it. Yeah. Maybe it's a little bit harder. So I think we start chapter 5 in next class. Yeah. So we're in the right time. So what is